So this problem is a limiting reactant problem, and if you notice, the way you know that is because I give you two different quantities for your reactants. I give you 31.6 grams of C3H6 and 21.6 grams of nitric oxide. And so what you're going to need to do is see how many grams of each product each of these guys will make. And remember, your product that you're looking for, it asks for the mass of C3H3N. So this guy is what you're going to be solving for. So what you do, I'm going to first work with C3H6. So I have 31.6 grams of C3H6. I need to get into grams of C3H3N, but in order to do that, I first need to use my mole-to-mole ratio. So I'm going to put grams of C3H6 on bottom and moles of C3H6 up top. And so the way that I do that, I use the molar mass of C3H6. So I put the 42.09 on bottom. I'm now in moles of C3H6. Now I want to get into moles of C3H3N, so to do that I put moles of C3H6 on bottom, so they'll cancel, and moles of C3H3N up top. Now where I get these values from, these are just the coefficients that are in front in this reaction. So I've got a 4 in front of C3H6, a 4 in front of C3H3N, so I'm good. Now I'm in moles of C3H3N, and finally I need to get into grams. So I do one more crisscross swish. I put moles of C3H3N on bottom and grams up top. The 53.07, that's the molar mass of C3H3N. And what I get when I round to the correct number of sig figs is 39.8 grams of C3H3N. Now I need to do the exact same thing, but now using the 21.6 grams of nitric oxide. So I put 21.6 grams of nitric oxide on right here. I've got to go first into moles of nitric oxide, so I put grams on bottom, moles up top. This 30 is the molar mass of NO. I'm now in moles of NO, so I put moles of NO on bottom and moles of C3H3N up top. Remember, that's what I'm trying to get into for this problem. Now, the 4 and the 6 come from the coefficient. So the 4 is the coefficient of C3H3N, and 6 is the coefficient for NO right here. Now I'm in moles of C3H3N. I just need to get into grams, so I put moles of C3H3N on bottom, grams up top, and this is my molar mass of C3H3N. Notice this last step is the exact same for both of them, because at this point I'm in moles of C3H3N. I can now get into grams. So what I get is 25.5 grams. So I have two different quantities of product. And if you remember from the s'more activity, if I have one marshmallow but 1,000 graham crackers, even though I have 1,000 graham crackers, I unfortunately can only make one s'more, because then I run out of my marshmallows, which are my limiting reactant. So in this problem, even though I could have made 39.8 grams of C3H3N based on the amount of C3H6 I started with, since I can only make 25.5 grams of that, of C3H3N with my NO, that's how much is going to be produced, because after that point I run out of NO. So I'm going to only make 25.5 grams of C3H3N, and my limiting reactant is NO because I run out of it. And that